So there you go. All right, here we go. Larry.
All right, so I'm Larry, and I'm going to talk about threat intelligence and how to get up and running very quickly. This talk is comes out of a series of discussions I had with Andre, and when I was earlier in this year, or last year, sorry, when I was trying to get my head around threat intelligence and what does it mean and how does it actually work in the real world. And then I learned about the platform called MISP, and that's kind of what we're going to build it on build on top of that. And this outline here is very loosely goes in lists out what we're going to talk about. So what is MISP? It's basically it's originally it comes out of Europe. It's a malware information sharing platform. It's completely open source and free. It standardizes threat intelligence, fully supports all the stuff out there like sticks, and all the way that threat intelligence is created and shared. Has robust event and indicator management. So the quality events you can create and the IOCs are quite nice. Has a powerful correlation engine, so any field within the event itself and the IOCs in an event can be very easily mapped and correlated to other events, so you can quickly follow trails of events and APTs and stuff like that. And it has a very nice flexible API, so completely configurable, customizable. You can program it, you can automate pretty much everything. And so what the core of MISP is actually an event, and it's the data about a security incident basically, and then everything related to that security incident is in that event. It has an event ID, and using that event ID, it can be correlated with other events, including all the contents that is contained within it. And yeah, there are push rules. So you can actually have rules around when the event gets shared, pushed, received, stored. So that's all there. And it's a very robust tagging system. So what the tagging system is you can it's a labeling system, which just labels out there like TLP. I don't know if you're familiar with traffic light protocol, but it's a kind of a sharing label. And how open is this event? How can it be shared? But there's many others. And these different tags have taxonomies. So the tag itself has structure and rules. And then there's the thing called Galaxy. Galaxy is basically is kind of an organization of metadata that you can attach to events. And there's many types of metadata families at Galaxies that are available. So an attribute in an event can have a data type such as just stuff typical of IOCs, networks, hashes for different types of malicious programs. So what's the primary purpose of creating MISP event for correlations? The primary purpose of creating and updating MISP events is to consume and link threat intel to alerts, notables, observables, cases, incidents, and stuff like that. So basically, the event itself is there so you can talk about the incident and create data about the incident. And then these events are mapped to threat intel, and it has the ability to run correlations. So you can actually, you can turn the correlations on and off if you want the correlations. So you'll have the mappings to other events, and then just some data about the maximum correlations. Okay, so what can MISP correlate? It can correlate pretty much everything, and then it goes into the types of attributes in the event. There's a list. There's antivirus, artifacts drop, attribution, external analysis, financial fraud. These are all categories of attributes within the event. And then within the event, as I said before, you can have the IOCs, which are file hashes, domain names, IP addresses, URLs, email addresses, and many others. And then this is just some information about the type of data to avoid, and the context for pivoting. Don't use stuff like IP destination dash port. And for pivoting, basically, that's when you have a certain type of data, and then you use that data to to build your investigation and to like go find other events and get more details about events that matter in your investigation. And then one thing that's great about MISP is that it's really amazing at sharing. And so these are just there's a lot of data here, so I'm providing some links. But the great thing is once you get your MISP instance up and running, you can actually map it to other MISP servers or organizations, and you can synchronize their data. You can add servers. You can create a whole community of MISP servers, and then you can have complex sharing systems for the intelligence. So this is just some links related to that. And then this is another sort of graphic about like how you can share data. So there's MISP instance A, which is one which has a bunch of organizations in it, and then if they create events, which are those little E's, and they want to share the E's with the quote on it, and then you could set up a group within MISP to share only the events that have certain tags or certain other labels to other organizations that would running on another instance somewhere else. So it's just a little map of how sharing can occur. And then within MISP itself, you can set up sharing groups. And this is just a little bit about the UI. So basically, sharing group is basically what events do you want to share with this other organization in another server. Once you've loaded a bunch of MISP instances in your MISP server, they'll all be available. You'll see the organizations in the remote server, and then you can create a group, and then you can actually specifically tag the events you want to share, and they automatically get synced to the other organization, or if you're in a sharing group, they automatically get synced to you. So it's a great way. You can create very, very granular, complex intelligence sharing networks. Another great thing is basically when you build these events, you want to do some. You have a bunch of IOCs, but you want to create an event so you can do some interesting correlations. So you can actually, in the event itself, you can create objects that are related IOCs and then correlate them. So let's say you have an attack tree, or you have a process, your child processes that are all related. You can actually create an object for each process, and the IOCs are associated with that process, and then you can link all those together in the same event. And then that's just some information about that. We'll do some more examples. This is just kind of an overview. Yeah, this is just a slide on some correlations. So these are all these command. You can actually add all these like command lines as MISP attributes in an event, and then you can correlate them with other events that have the same command line within the MISP event. So just a little thing on that. So basically this is just some more stuff on tracking with MISP objects, and we'll get a little more detail with this. Yeah, so just some information on that. So you've got a bunch of events in MISP, and you're sharing them, and then you want to bring more data in, and these are just different ways of doing it. Using feeds. This is an example of a Twitter feed, and it's basically there's a tweet feed is an actual Twitter channel, and you can pull it into MISP. All the IOCs that appear in tweet feed. This is just an article, online article with Python code that shows you how to do that. All right, so we're just going to get a little bit into installing MISP. So I wanted to communicate the quickest way to do it, and the quickest way to get MISP up and running is basically to use this Docker module, and this is at this GitHub address, and it's quite easy to do. So basically, once you pull it from GitHub, you basically just copy the template.m to m, and then you fill out a few pieces of information like here, and then that's basically it. And then basically that's the Docker compose, and you just basically just Docker compose up, and you're up and running. One thing to make sure about is make sure that you have a base URL where you're gonna host it. And at whatever the public IP or whatever IP is, or the domain, that's the most important thing, the base URL. The rest of it actually has some defaults even, and there's actually a default password as well. Here I just chose a password, but anyway, so that's basically it. These all come from the environment file, so you don't really have to do much even in Docker Compose YAML, but it can be customized, and that's it. So basically, these are the defaults. If you don't even touch anything, if you just copy over the environment and then run it, you're pretty much ready to go. Just add the IP address or domain, that's it. And then you can log in and you're ready to go. One thing you want to do once you're up and running is you basically change the default admin password. Create some organizations if you want, create a user. Sync the galaxies and taxonomies. We'll talk a little about those later, just so you get the latest ones. And then configure the TLP taxonomy. You'll need this because most events will have at least a TLP tag. So that's just the traffic light protocol basic sharing tag of how sensitive the event is. There's other taxonomies, you can browse through it. Anyway. So quickly, we're going to go into how to create an event basically from scratch. So you're going to once you create an event, you're going to get this little screen, and it's basically going to ask you for a few fields here. How is it going to be shared? The threat level, any type of analysis that occurred, and then you can also link it to other events for correlation, like is this related to another event, and you can add a list of events that it's related to. So after you've created some events, you may want to populate the event with content, and there's just some different ways of populating the event. You can use a JSON file, there's free text import, there's some templates, there's an OpenIOC import, Threat Connect import, and some other things. And these are just ways of quick, if you have, so some events can have, if there's a lot of attributes in an event, they can have thousands of attributes. So if you're going to create a big, if you're analyzing a very complex campaign that has a lot of data, and the event has a lot of information, there's going to be a lot of IOCs, a lot of attributes. You may want to use a bulk import, and these are just some ways of doing that. So basically, free text import, you can copy and paste a list of indicators, and then you can just go into the UI and just pull it right in, and it'll add the attributes. Okay, so a little bit about what this looks like in the UI. So I'm just going to go through a scenario of adding the event itself. So this is going to be from an online report at that URL. It's the Azerol malware campaign, and so basically we're creating this event from scratch, and so this is the basic event here. There's the event ID, and then we're going to add some attributes to it. So yeah, just like we talked about earlier. This is shared all communities, threat level is high, analysis initial, and then what you do is once you have the basic event framework created. You have the core base event. You want to add information to it. Now, there's this thing called Galaxy cluster, and what a Galaxy cluster is there are different. It's metadata that's specific to a type of attribute or incident. Like so here, we're going to add the MITRE ATT&CK cluster, and MITRE ATT&CK is going to give you a bunch of TTPs you can add to the event. So basically, we're adding the MITRE ATT&CK cluster, and then we're basically going to add a bunch of TTPs from that cluster to the event. So these are the actual TTPs within the event that you care about, that will be directly related to this particular malware campaign. Then you can there's another Galaxy cluster from Malpedia. And then because this particular piece of malware uses Cobalt Strike as a dropper, you can add information. Oh, not this particular one, but yeah. So this actually is the Azerol one. So it's actually not Cobalt Strike. But anyway, so we can go into Malpedia and add Azerol specifically and its derivatives as part of the event. And so you just drop that in. And then, from the research, there was a whole. Usually, when you see a research article, you'll see at the end a bunch of TTPs and a bunch of IOCs. You can actually, once you add the TTPs to the event, you can actually add the actual attributes as well. And this is where the attributes are added to the event. And so here we're just adding basically a hash of one of the payloads within the malware campaign. We're adding that directly to the event as an attribute. And then if you have a lot of attributes that are similar, you can add it as an object. So here's a template for a link file, and then if this link file pulls in a bunch of other payloads, you can add the attributes of all those payloads, all their hashes, and all the scripts that are included in that's being called by the link file. You can add that as an object, and you can add the whole object to the MISP event. So once you've got everything added, this is kind of what it looks like in MISP. It's basically a completed event, has an object for the link file, and then it has a whole bunch of other TTPs or IOCs related to the network, and then some other payload stuff. And this is all in there. And then you can actually tag and share all this as well if it needs more further granular detail. So that's basically the manual process of adding events. And usually when you first start up, I recommend to get comfortable adding a bunch of events that matter to you, going out, getting some research reports, building events, describing them, loading the TTPs and the IOCs from the event into your particular event in your MISP server. Now, what you can also do once you build out some events, and then we'll also talk a little bit about loading events from some external sources, like the Alien Vault OTX, which is pretty good. So anyway, so in MISP you can subscribe to feeds. There's a whole bunch of feeds that you can subscribe to get external intelligence data in the UI. Now, these feeds are sometimes like a fire hose of data, and I recommend just loading a feed. And so the MISP server has a Redis. Live Redis database in it, and so you can actually just cache the data and the IOCs from the feeds, and you can search them. So you can actually pull in a bunch of feeds into the cache, search the cache for IOCs and events that matter to you, and then only import those, or just search the feeds for correlations with the events you've actually created and loaded into your MISP instance. So it's a little bit about that. You can also create a scheduled task that periodically will go out and refresh your feed caches. Yeah, so this is the screen for the feed, and these are just there's probably in the default there's probably like maybe 80 feeds that you can kind of look through, and then you just go in and click these and you can cache them into the Redis database, or you can download them too if you want. But sometimes you can have tens of thousands of events in your MISP database, and it gets to be pretty crazy. And so another thing is you can add a decay model to the event, and decay models basically will expire the IOCs and the data in the event. And there's like a phishing and a network. There's a couple of decay models that are available natively, and you can just add those to the events that matter to you, and then eventually they will expire. So as the intelligence gets stale, you'll probably, or it's not as important, this decay model will help kind of prune the events. And then there's actually a tool in there in the MISP PR where you can actually create your own custom decay model for the event, in the events that matter to you. So this is a little bit about, like when I first started with MISP, I basically, I was a little weary based on some of my discussions of pulling in a bunch of feeds. So basically I just used this script, and with this, you can do it with this command line, and then you basically pull. This is a very high quality. It's a very high quality event stream, and if you use this command that's here, it'll pull in all these events into your MISP instance. I would say usually when you first get started, it'll pull in about 4,000 or 5,000 events that are actually pretty relevant to real-time campaigns out there, and you'll get to see a little bit about what's going on. It's pretty neat to go through it, and then you can customize it. You can add your own events. Really, the most important thing is there's this bulk tag. You'll want to bulk tag these events, and also 2 IDS is an important flag, because then you'll be able to pull this into Suricata or IDSs and other things like CrowdStrike EDRs, and you can pull all this stuff in there if they're tagged to IDS, because then you can be able to export them. We'll talk a little bit about that. So basically, how do you get at the events programmatically? There's the MISP API, and pretty much anything that MISP provides, you can program with the MISP API. So you can do anything you want with events. You can do anything you want with attributes. You can share and set up sharing and distribution with the API. You can administer users and organizations. You can tag stuff. You can search taxonomies, and you can manage sightings. Like if there's a citing attribute within the event, if the event's been cited, and that's all programmable by the API. And then how do you program the API? You use PyMISP, and it's basically a Python library that encapsulates the MISP REST API. It's great for searching and exporting data. I use it a lot for that. And that the more familiar you get with the MISP search and export, the more awesome it is, because you have complete control over the events and attributes. You can use them, you can share them, import them into your security tools. Good stuff. Yeah, automation and scripting. It's very easy to use as well, and we'll get into some code soon. Yeah, to use the API, you really only need the IP address or the domain of your MISP server, and a key. You create a key inside the MISP console, and then you're pretty much ready to go. And this is just the base. This is all you need to get started. You basically you install PyMISP using pip, and then you add this to your code, and then you create what's called a MISP object, which is down there, and then from that MISP object you can interact pretty much whatever you want, however you want with the MISP server. And now, if you're going to load events, if you want to, if you, let's say, you know, we talked previously about the UI and how to create them in the UI. Now, if you actually want to, you have a bunch of IOCs, if you put them in this JSON format, and you basically can create these IOCs from, you know, anywhere you want, and then put them in this JSON format, and then you can load them. And this is very simple. Here's some code to load it. Yeah, you basically connect to the MISP server, you open the file, and then you add the event to the server, and that's it. Then they just appear. You actually have to add it to an event. Sorry, you can create the event with the API as well, but you can add it to a particular event. You just put it in the yeah. Here's some other tools that integrate nicely with MISP. There's phishing information script, Suricata, so you can search for indicators that you can use in your Suricata. The polarity domain analysis platform it can be integrated, and if you use Sigma rules, you can import your Sigma rules as well. This is some detail about MISP search. So this is really what's really important, and the more familiar you get with the MISP search capability in PyMISP, the more you can search the data. And these are just some of the things you can use within the search, the MISP search function within PyMISP. And this is just some of the things you can do. You can like look for threat levels. You can look for different types of analysis, attributes. Yeah, so very granular stuff about the event, whether the event has the two IDS flags, you can export it to a security tool, you know, different, yeah, hashes, oops, yeah. And then this is how you actually, that's kind of like the different things you can search on, and this is actually how you can build a search with filters. So basically, all those things that you can build very complex searches, and here's an example of that. So you know, this is just searches the MISP for event ID at that date with those tags and threat levels and stuff. So yeah, you can search the events that way. And this is a little bit more about the search function. Fairly robust. So these are all things you can use to search the events with. And so another thing is, which I like to use, is Jupyter Notebook. So basically, all the stuff we talked about, you could do straight from a Jupyter Notebook directly connected to your MISP instance. And this is very simple. You can install it with Jupyter Notebooks with those two lines of code. You can actually, there's a Jupyter extension in Visual Studio code, which is actually quite nice, because it also integrates with Markdown, and you can add, you can document your research with a Markdown in the Visual Studio Jupyter Notebook. Very nice. You can create a config.py, and in that config.py, you just put in your MISP URL and your MISP key, and then you can use that straight in the notebook code. And then, so as part of this talk, sometime today, I'm opening up a GitHub, and there's all the stuff we talked about. There's tons of code already there. There's a notebook with tons of searches and conversions between MISP and sticks and all kinds of stuff in that Jupyter Notebook that I'm releasing. And this is it. This is how you use MISP with Jupyter. You basically add this to a cell, create your MISP object, and you're pretty much ready to go. Then you can use the MISP object in other cells, and you can build your searches and do your analysis. And here's a sample Jupyter cell. Basically, I'm just searching for that. So basically, this was just basically what I talked about, the OTX feed. So all that data that came down from the OTX feed, I wanted to see that and have it printed out in a very easy to read way, especially if there's a lot of events. So this is just a little piece of code that does that. It just searches the MISP instance for that particular tag and prints out some data about the event for you. So also you can integrate it very easily with other SIMs. So here's a little example of integrating your MISP instance with Elastic Agent, which is I'm not sure how many people have used Elastic Agent, but the Elastic Agent has a very nice integration with the MISP. It's all pretty much ready to go. It automatically indexes everything with your events in the Elk stack. Now, as part of the GitHub, I actually wrote a Flask web service that lets you customize searches using the MISP API that will do custom searches for you against a MISP instance, and so that will be in the source code. And then you can run that as a web service. You can use curl against it, and then I also have a sample logstash HTTP polar in the code, which is going to just basically you'll be able to configure it to search stuff in the web service, and then you insert it into an Elasticsearch index. So that's all ready to go. So if you want to play around with that, that will be available. And then Sentinel, this is something I've been working on for my own personal work, is integrating MISP with Sentinel. So Sentinel has a TI module, and then with that TI module, you can get the indicators, and then you can build KQL searches from those indicators, which is really nice. So basically integrates, used to integrate via the Microsoft Graph, but Microsoft recently deprecated the Graph for indicators, and now is using what's called the Upload Indicators API, which is completely sticks-based. Now, I've had some problems because it seems like in typical Microsoft fashion, it's not 100% sticks compatible, even though they say it is. So sometimes you have to tweak it a little bit. But there's a script out there which is fairly nice, which is written by one of the MISP core contributors. It's MISP to Sentinel. This will take MISP events from your MISP instance and put them right into Sentinel. Basically it'll basically change the MISP event into a sticks event and then insert it into the indicators API, and then you'll see it in the Sentinel TI database. And it also has Azure function support, which is kind of nice. So you can set up an Azure function and call MISP to Sentinel to import the MISP events and IOCs. And so I've had some trouble with because of stuff like YARA rules. This script doesn't seem to like YARA rules, and the author is like, well, YARA rules aren't really supported well by Sentinel, but so I've got a script that I'm going to include that actually does the MISP to sticks translation for you and shows you what the sticks object looks like in the Jupyter Notebook, so that you can actually see what you're inserting into Sentinel. So that's part of the Jupyter Notebook release. And so MISP sticks, yeah, so that's basically, MISP provides this library so that if your TI platform or tool requires sticks, it'll convert the MISP object to sticks, basically. And yeah, so that this I sometimes take it with a grain of salt. Maps MISP objects and galaxies with semantically similar objects and sticks, can be a little sticky, and that's why I usually like to play around with the conversion before I insert into Sentinel. Yeah, so this is kind of what it looks like when you get into your Sentinel Threat Intelligence, and then you can grab, using in KQL, you can grab any one of these IOCs, and then you can build some detections, and then you can push them out to Defender if you're using Defender in your environment. And it's a nice way to add custom intelligence to. So if you build an event in MISP and about a particular ransomware malware that you worry about in your organization, you can import it into Sentinel, build a detection for it, and then push it out to all your Defender endpoints, which I do quite a bit. Yeah, so now we'll just get into the last few details here about distributing IOCs. So so as we talked about in the MISP event, there's a bunch of IOCs in there, right? And so sometimes you need to export them and to use them like we talked about. You can sync them to SIM, you can sync them to Sentinel. But sometimes you just need the raw list of the IOCs and to import them in another tool. So that's why the Python code is really nice. The MISP API, you can just export all the IOCs with the 2IDs set to 1, and then you just create that file with those JSON objects, or you can create a CSV, whatever the tool, or just a list of name value list in text, and to import them into your what a tool of choice. And so yeah, so basically, yeah, this is if anybody out there uses CrowdStrike. So CrowdStrike has got an IOC API, Python API that you can use to upload IOCs with, and this actually works really nicely with MISP as well. You can just use your PyMISP script, export all the indicators that you care about with the 2IDs flag, and then in the same Python script you can just use this particular API to import it into your CrowdStrike endpoints. And I think that's pretty much it. So yeah, so to conclude, MISP is a great way to learn and operationalize threat intelligence. Like I had no idea about threat intelligence, and then until I started playing with it. Now I'm like kind of creating my own events, doing my own research, learning about different attacks, integrating them with tools. It's really, as you saw, it's really just a couple Docker containers to get up and running. It's easy to get started, but at the same time, it's a very mature and deep platform. It's actually used by NATO to share threat intelligence. So, there's quite a bit out there. It's a very helpful community. So I'm gonna check in a bunch of code, and it'll be available sometime today. And if anybody has any questions, you can just email me or talk to Andre on Discord. That's basically it.
Any questions?
I got a question.
Sure.
Are you going to share your presentation on Discord as well?
Sure.
Yeah.
I'll do it, yeah. And then as soon as I have a couple things to check in, sometime later tonight, you can just, all the code will be available on GitHub. Yeah, tons of examples, way more than I even covered in the talk.
Thanks.
Anybody else? Nobody's going to stand between us and lunch. Thank you very much, Larry and Andre on Discord. So thanks, guys. Good job. You impressed everybody we got a cord.